Good day everyone. I'm Ariel Policarpio from BSE 3B Mathematics. So our topic for today's video is all about Euler's theorem. Euler's theorem states that if GCD of A and N is equal to 1, then A pi of N is congruent to 1 mod N. Here, pi of N is Euler's tangent function. The number of integers in set 1 to n minus 1, which are relatively prime to n. Leonhard Euler was the one who discovered Euler's theorem. In his theorem, there are 4 rules. Rule number 1 is p minus 1, where p is prime. Rule number 2 is p raised to n minus p raised to n minus 1, where n is the prime factors. Rule number 3 is tangent m times tangent n. Rule number 4 are the very applicable rule, which is n times the quantity of 1 minus 1 over p sub 1 times the quantity of 1 minus 1 over p sub 2 until 1 minus 1 over p sub k. So, for us to understand it more, let us have this example. 11 raised to 121 mod of 35. So in this case, in this problem, we will use the rule number 4, which is n times the quantity of 1 minus 1 over p sub 1 times the quantity of 1 minus 1 over p sub 2, where the n is the divisor and p sub 1 and p sub 2 are the prime numbers of the divisor, prime factors of the divisor rather. So let us have first get the prime factors of 35. So the prime factors of 35 is 5 and 7. 5 times 7 is 35. So let us just substitute the given value, where n is the divisor, which is 35, times the quantity of 1 minus 1 over first prime factor, which is 5, times the quantity of 1 minus 1 over the second prime factor, which is 7. So let us solve this. 35 times 5 over 5 minus 1 over 5 times the quantity of 7 over 7 minus 1 over 7. So the answer is 35 times the quantity of 4 over 5 times the quantity of 6 over 7. So when you solve this, we will get the answer of 24. So our tangent is 24. So we will use our tangent 24 in our given, since 11 raised to 24 is congruent to 1 mod 35. So we will divide the tangent 24 into 121. So 11 raised to 20 to the 24th power. 121 divided by 24 is 5. But 5 times 24 is just 120. So there is a remaining 1 power. So we have to multiply it in 11 raised to 1. So since 11 raised to 24 is just equal to 1, let us write 1 raised to 5 times 11. So 1 raised to 5 is just 1 times 11. So our answer here is 11 mod of 35. Meaning when you divide 11 raised to 121 into 35, you will get the remainder of 11. So 11 is the remainder and 35 is the divisor. So to check it, let us now use the rule number 3. So same given problem, 11 raised to 121 mod of 35. So our rule number 3 is tangent m times tangent n. So where m and n are the prime factors of the divisor. So our divisor here is 35. So what are the prime factors of 35? 5 and 7. So substitute the given value. Tangent 5 times the tangent 7. So in this case, we will use also the rule number 1, which is p minus 1, where p is the prime factor. So the 5 and 7. We will reduce these two by 1. So tangent 5 minus 1 times tangent 7 minus 1. So our answer here is tangent 5 minus 1 is 4 times tangent 7 minus 1 is 6. So tangent 4 times tangent 6 is equal to tangent 24. So we will use again 24 in our given. Since 11 raised to 24 are congruent to 1 mod 35. 1 mod 35. So we will divide 121 by 24. So 11 to the 24th power. So 121 divided by 24 is 5. But 5 times 24 is just 120. So there is a remaining 1 power. So we have to multiply it by 11 raised to 1 power to first power. So since 11 raised to 24 is congruent to 1 mod 35, let us simplify this to 1. Let us write 1. So raised to 5 times 11. 1 raised to 5 is just equal to 1 times 11. So 1 times 11 is equal to 11. So meaning 11 mod of 35. So meaning when you divide 11 raised to 121 into 35, you will get the remainder of 11. So 11 is the remainder and the 35 is the divisor.